before I start this video, I want to let you all know that I talked to the big man himself, the GOAT, the man, the myth, the legend. And he told me that this question was really cruel. So, a word of warning there. If you all got this question wrong like I did, you know why. A thin rod of length L and mass M is placed in a horizontal table pivoted about an axle through its center. The rotational inertia of the rod about its center is 112 ml squared. A spring with spring constant K is fixed at a point on a table and perpendicularly, to one end of the rod. The rod is displaced a small angle theta from equilibrium and released, as shown in the top view figure. The rod oscillates in simple harmonic motion with period t. What is the mass of the rod? So, you may be thinking, you see, I have t of pendulum, because pendulum, or whatever, is 2 pi I mgl. And then I also have tis of t of spring, the period of the spring, which is this. And then, I could solve for, this. But wrong! This is wrong! Because apparently there is zero pendulum. It is just torque. I'm not joking. It is wonderful in it. So let's scrap all of that and actually get to the solution. We're given the rotational inertia, and we're given the fact that there's like a spring causing stuff. Okay, so my point is that let's write down some equations. T equals to I alpha, which is the torque. Torque is also equal to RF sine theta. So you can notice that the force causing the torque is going to be the spring, so we can substitute this in as F equals to negative kx, so it will be R negative kx sine theta. Sine theta always, almost always, in like all these kinds of questions, crosses out to 1, so we don't have to worry about that. So let's put this back in. We have I alpha, is negative RKX. And we have R, right, which is 1 over 2L. We also have we also have X, because X is like the vertical analog of theta, so we want to substitute that. We also have I, which is 1 over 12 ml squared. Stop. Like, basically, this is just R, but we have to multiply by, Okay, so let's just simplify all this, and we get So, fellas, does this look familiar yet? That's what I thought. Now, does this look familiar? All right, let's move this term to that. And now we will have alpha is equal to 12 k over 4m theta. And now you look at this term and you're like, holy moly, that looks really familiar. And I'm like, yeah, that's what I thought. So realize this cancel 3, and we have this term corresponds to this term. So now we have this omega squared, which is 3k over m. So omega is this. So the period is 2 pi m over 3k. So yeah, that's an awfully long process, isn't it? Now we want to solve for m, which is the mass of the rod. Hence, to get rid of this, t squared is equal to 4 pi squared m 3k. We want to solve for this. So we have t squared over 4 pi squared. I'm sure this formula looks really familiar to you guys. To solve for m, we now have t squared over 4 pi squared. And we're dividing it, and we're multiplying this over here because we want to solve for m by 3k. And now let's rewrite all this. And now, that looks really similar to all the answer choices, because if you rewrite it again, you realize that this answer is answer choice B.